last week's video, we started a new series on rendering water material. And last week we were mostly focused on creating the ripples on the surface of the water. This week we're going to talk about depth opacity and depth color. Before we jump into depth opacity and depth color, what I wanted to do is show you a completed water shader that I've been working on so that you can see where we're headed. You can see that we're using the ripples that we created from last week, and we've also added our depth opacity and our depth color that we're going to learn about this week. And in addition to those two things, we've also got reflection and refraction. You can see the water under the surface here, or the rocks under the surface, are distorted or refracted by the ripples on the surface. And if we look toward the horizon a bit, you can see that the water has some really nice reflections. So those are the things that we're going to be talking about next week. This week we're going to talk about the depth opacity and the depth color. So let's jump right into it. What we're going to do is assign the water shader that we created last week to our surface, which is called our water ripples demo. And you can see that now all I have is the ripples. I don't have any depth and I don't have any opacity. I've got a little bit of reflection going on, but no refraction. So let's jump over to our shader. This is the one that we created last week, and we'll pick up right where we left off. The first thing that we need to do is set some settings on the root node. So right now, if I select the root node here, you can see that my shading, that my material, my blend mode is set to opaque. And the first thing that I need to do is to set this to translucent. And setting this to translucent is going to allow me to create a material that has opacity that I can see through to show me what's on the other side of the surface. Now, using a material with opacity, I needed to create a little demo scene. And so that's what I've done here, because there are certain properties of my water shader that will not show up in my preview window here. And so I put together just a very simple demo scene, and I'll fly around that just really quick so you can see what it is. I just copied some of these floor slabs. I copied this small rock that comes with Unreal and just kind of made a little test scene that we can use for showing off our water. Okay, so we set our shader to be translucent, and the next thing that we need to do is figure out the depth, because there are two things that control the opacity of water. One of them is the angle that you're looking at the surface, and the other one is how deep the water is. When water gets deeper and deeper, it gets more and more opaque. So we need some way of measuring the depth of the water. And there are two nodes that I want to show you that we can use to measure the depth. The first one is called scene depth, and the next one is called pixel depth. And in order to explain what these two nodes do, I want to switch over to a little bit of an illustration to help kind of walk you through visually what these nodes are doing. Okay, so this illustration is our scene. You can see that we've got water down here on the bottom, and below the water we've got the rocks that are on the bed underneath the water. And here's a little icon, a graphic that represents where our camera is. And so we need to measure the distance from the camera into the scene. And so that's what our first node is, our scene depth. So you can see that our scene depth measures the distance from where our camera is all the way through the water to the bottom. This sends a ray that goes through the current transparent object and hits whatever is behind it. So I get the information that this node gives me is the distance from my camera to whatever is behind my water surface. The other node that I have is called pixel depth, and what this does is it gives me the distance from the camera to the water surface. So here with the two of these things, I have the distance from my camera to the water's surface, and I also have the distance from my camera to whatever's behind it. So if I subtract the pixel depth from the scene depth, I get this new vector, this blue one, that is the distance from the water's surface to whatever's behind the water along the vector of the camera. So that's going to give me depth of the water. Now, there are two ways of calculating depth, and this is the first one. So let's take a look. Let's jump back into Unreal and take a look at the results that this is going to give us. We'll build the shader and take a look at what we're going to get from this. All right, so I have my scene depth and my pixel depth, and I just want to add a subtract node to the scene, and I want to subtract my pixel depth from my scene depth. And like I said before, this is going to give us that blue vector in the illustration that was the distance from the surface of the water to whatever is behind it. Now, in order to control this a little bit, I want to add a divide. And I'm going to divide by a constant. And the value of this constant is going to be, I'm just going to give it a value of 100 for now. And what this is it's the depth of the water, at what depth the water becomes completely opaque. And I put 100, and that's in centimeters. So I'm going to say my water goes from completely transparent to completely opaque in the range of 100 centimeters. And then the other thing that I'm going to do is apply a power node so that I can control the fall off curve of the water. And I'll show you what both of these two do in just a second. So for my power node, I'm going to add a constant, and then I'm going to give that a value of 0.2. Okay, let's pass that into base color just temporarily. I'm going to disconnect my normal here and pass this into base color just temporarily so that I can see what the results are going to be. And I'm going to save my shader and switch back to my scene so that you can see what this depth is doing. Okay, so you can see that I have something that is sort of an approximation of depth. Right here on the surface, I've got this little bit of blackness, and then it falls off and goes white the deeper the water is. And that's pretty cool. Now there is one thing that I need to do to adjust this so that we can see it a little bit better. The first thing that I'm going to do is set my scene to unlit, just so that we can only look at the color. And then the next thing that I'm going to do is, because the data that's passed into this base color pin is adjusted for gamma, I'm going to undo that adjustment. And this power node that I'm adding here is just purely for visualization, just so that we can see linear data even though it's been adjusted for gamma. So I'm going to raise it to a power of 2.2, and that should give us a little bit more of a correct representation of the data that we're generating here. So I'll switch over to my scene, and now you can see that I've got this depth going on. So here near the surface where the rock is poking out, the rock is black, and then as it gets deeper, it gets more and more white. So this is the data that I'm looking for. I need to figure out, or I need a value, or to create a mask that is black on the surface, so the opacity is near 0, and then as I get deeper and deeper, it gets more white and more white. There is a problem with the way that I'm calculating this though, and you can see it right here as I rotate the camera around. As I'm looking straight down, I get this kind of depth value, but then as I rotate my camera to more of a shallow viewing angle, the depth information is changing, and that's kind of weird. So why is that? Well, let's jump back to our slides and I'll illustrate the point. So here's our scene. And the depth that we're calculating is from the surface of the water down to whatever's behind the water, whatever's under the water. But the problem is I'm rotating my camera to more of a shallow angle now. And as I rotate it, you can see that this depth vector is getting longer. So the shallower my angle, the more opaque my water is going to appear. And that's not necessarily correct. What we want to compute is a correct depth, which is actually more like this. We want to take the value where the camera vector hits the water and then compute the depth straight down from there to whatever's underneath the water. So let's switch back to Unreal again, and I'm going to show you how to compute this actual depth value. All right, so we're going to take our scene depth and our pixel depth, and instead of subtracting them, I'm going to divide them. So I'm going to add a divide node, and I'm going to divide my scene depth by my pixel depth. And now what I want to do is I want to bring in my world space position, and I also want to bring in my camera position. All right, so I can use both of these, but before I use them, I need to adjust them based on the height of the water. And so I'm going to create a third vector here. I've got a position for my world position and my camera position, but I need to create a third vector for the height of my water. So I'm going to add a constant 2 vector that's just set to 0, and then my height I'm going to add as its own value. So this is the height of my water, this constant that I'm creating here. And I happen to know that if I switch back to my scene here and select my water, I can see that it's located at 70 above the origin of the world. And so I'm going to put a value of 70 in here. And I'm going to take this vector and I'm going to subtract it from both my camera position and my absolute world position. Alright, so now I've transformed my absolute world position and my camera position into the space of the water height. And so now I can cast a ray from the absolute world position to the camera position. I'll do that by using a subtract. And now I'm going to multiply by this value up here that I calculated, the scene depth. Okay, and then finally I'm going to add these two values together. And I only actually need the Z component because it's the height that I'm looking for. And so I'm going to move this over, and I'm going to add a component mask, and I only want the Z. So I'm going to turn off the X and the Y, just leave the Z. And then the last thing that I need to do is invert it. So I'm going to do a 1 minus. And then this value I'm going to pass into here, like this. Okay, so now I've created an accurate depth value. Now there is a drawback to using this accurate depth value. If you have a water plane that's not flat, like if you're doing a river that's running down a hill, you wouldn't be able to get this height value very well. And so you would want to use this approximation where you just subtract the pixel depth from the scene depth in that case. Or if you have tons of different water planes and you don't want to worry about inputting the height of each one, you could use this approximation instead. But in cases where you can compute this height and apply it, it's much better to use this more accurate version. All right, let's save this and jump back over and see what it looks like in our scene. All right, so my scene turned out to be solid white, and that's because I made one mistake in the shader. We need to switch back here, and instead of adding the result of this subtract, we need to add the result of this subtract, and that should give us what we're looking for. All right, so now you can see that as I'm moving around the scene, my depth is staying constant, and that's exactly what I'm looking for. Okay, now there are two more contributing factors to opacity. There's the angle that you're looking at it, and then there's also one more little thing that I want to do on the very edges. So let's talk about the angle. To measure the angle between the surface and my viewing angle, we're going to use a node called Fresnel. So I'm going to skip over here and come in here and add a Fresnel node. And internally, what this node does is it does a dot product between the eye vector and the surface normal. And it will return a value of 1 if those two vectors are parallel, but if they're perpendicular, it will return a value of 0. There's also an exponent value here, and I need to set this value to something that's a little bit more appropriate for water. So in this case, I'm going to set it to 3 instead of 5. And what I'm going to do is come down here to where I've got this power coming out, and I'm going to add in my Fresnel. And now let's see what I get with my mask. Oh, actually, before I do that, I need to saturate the result to make sure that I don't go over a value of 1. So this will clamp it between 0 and 1. Okay, so now you can see I have my depth, but when I'm looking at it at an angle like this, the depth is opaque, and when I'm looking down into the water like this, there's more transparent. But as my angle changes, I'm able to get some opacity, and that's nice. Now there is one thing that I forgot to do, and that is I forgot to use my normal, because my normal that I have here actually should be the normal that I'm generating with my ripples. Now there is one nice trick that you can do in Unreal. Whatever you pass in, because let me back up a little bit. Whatever I use in this normal needs to be in world space. And these ripples that we computed last week in that tutorial, these are actually in tangent space. But what happens is, whatever I pass into the normal socket on the root here, I can access this normal here but it will be computed, or it'll be converted to world space. So I'm going to plug this normal in, and now I'm going to bring in a new node that's called pixel normal WS, and the WS stands for world space. So if I pass that into my normal socket, my Fresnel term will now be using the normal that I computed with all of this, but it's been transformed into world space, which is what I need to do my Fresnel computation. So let's take a look and see what that gives us as a result. And once again, it's giving us not the result that I was expecting, and that is because I forgot a setting. So let's switch back to the shader, and if I come over here to the root node and select it, I need to set my lighting mode. See how it's set to volumetric non-directional? I actually need to set my lighting mode to surface translucency volume. And when I had it to volumetric non-directional, I don't know if you noticed, but this normal socket is grayed out. And what that means is that it's not accepting input. This particular lighting mode doesn't use normal input. And so I need to change my lighting mode to surface translucency volume, which now allows me to input a normal. Okay, so let's save this and switch back to the scene. And here you go. So we've got the surface ripples happening, and as I look down into it, we got some nice depth. But as I change my view angle, we get some more opaque water. And you also can see that the Fresnel term is doing some really nice effects with the surface ripples. Okay, so we're almost ready to use this opacity, but there is one more thing that I want to do, one more trick up my sleeve. So let's switch back to the shader again, and this time we're going to add another node called DepthFade. And what the depth fade node is going to allow us to do is so if we switch back to the scene here, you can see that right around the edges, there's this really hard line between the rocks and the water. And what I want to do is kind of fade this out so that right at the edges of the water, there's a nice transition instead of a hard line. So I'm going to add in this depth fade node. And so just right here after my saturate, I'm going to multiply this value that we've computed by the depth fade. And if I come here to the depth fade mode, you can see that I have a couple of parameters, the opacity and the fade default. And in my case, I'm going to set, now this is a value in centimeters, and I'm going to set my centimeters to 30 so that it's just fading off right at the edge. And we'll pass that in again. So now you can see all the places where the rocks are intersecting the water plane. I've got this darker opacity value, which means the water is going to be more transparent in those areas. Okay, so we've been passing our opacity value into the color, and that's just so that we could see what it looked like. But now we actually need, now that we've computed this value correctly, we actually need to pass it into the opacity. So I can take the result of this multiply here and pass it into my opacity socket, and I can get rid of this power node here that's going into my base color. So let's save that and take a look at what it looks like in our scene when we're actually using the opacity value that we computed as opacity for the water. Alright, cool. So you can see that my water is the default dark black color in places where it's opaque, and where it's transparent you can see through it down into the depths, and that's the result that we're looking for. Okay, the last thing that we need to do is get some color for our water. And so what we can do now is what we observed in the reference footage that we watched is that the water changes color as it gets deeper. And we have our depth value right here. So all we need to do is add a linear interpolation node, and we can use one color for the water where it's shallow, and then the other color for the water where it's deep. And I've worked on this a little bit, and I found some colors that I really like. This one is kind of a light blue color, and then this one is a dark blue color. And so I'm going to pass this one into the B socket and this one into the A socket. And then instead of leaving this empty, I'm going to wire the result of this lerp into my base color. Alright, so you can see that I've got this nice light blue color where the water is shallow, and where it's deep, it turns kind of that darker blue color. Now I can turn my lighting back on because I'm looking at it unlit, and you can see I'm getting a little bit more realistic looking results. Alright, so just to reiterate here, we've computed depth using our world space position, our camera position, our scene depth, and our pixel depth. And then we're dividing that depth by our maximum depth, which right now is 100, but if you wanted your water to be clearer further down, you could increase this depth value to something over 100. And then we're adjusting the power, or the fall off curve on the water, and we're using a value of 0.2, but you could use something else if you wanted to. And then, in order to make our water more opaque when you're looking at it at glancing angles, we're adding a Fresnel term here. And then finally, to make our water transparent on the edges, we're adding a little bit of depth fade. And then that is our opacity, and then we're also using our depth to determine a light blue color for shallow water and a darker blue color for deep water. So that's the tutorial for today. Remember, next week we're going to talk about reflections and refractions and end up with the water that I showed you at the very beginning. So be sure to subscribe to the channel and hit the notification bell so that you'll know when a new tutorial comes out. I try to publish these every Thursday. I hope you enjoy it, and I'll see you in the next video.